We have a number of questions that use the same exhibit. First question here, which level of coupon would the Swiss government choose if its goal is to minimize the premium over par value for a 5-year debt issue? So look at our spot rates for the first 5 years, they're all negative. Which means any coupon above those rates would end up being a premium bond. So which coupon would we choose to minimize the premium? 1%, 0.5, or 0? Obviously, we'd try to choose the lowest possible coupon, 0%. The Australian government is considering issuing 3-year bonds with a 3% coupon with annual payments. Given the spot rates in Australia, the price is closest to. We're looking at a 3-year bond, so we need the first 3 spot rates. They're almost 0. Look how close they are to 0, right? So our numerators 3, 3, and 103, because it's a 3-year bond. Our first discount rate, because this is 0.0272%, you have to put 2 other zeros in front of it. 1.000272. Next one 675. Next one 3003. Power of 2, power of 3. Calculated out 108.07. So this one is a rather detailed question for calculation. Suppose the 1-year and 2-year spot rates in Canada move upward by 20 basis points, but the 3-year spot rate remains unchanged. Which of the following best reflects the updated 3-year Canadian par rate? And we have increases by, which means we need the original par rate. We have to take the first 3 spots and calculate a par rate. Then we have to increase the 1-year and the 2-year by 20 basis points and calculate a new par rate. Let's just increase the 1-year and the 2-year by 20 basis points and calculate our discount factors. Here's our 3 discount factors. Here's the sum of the discount factors. And here, right up here, is our fixed rate, 0.7967885, based on these calculations. And to see how that compared with the original spot rates, these are our original discount rates if we use these particular rates. There's the sum, and we would calculate our fixed rate here. And then we just take the difference between the 2 fixed rates and we get 0.0000159. 2 decimal places is right there. So this is 0.159 basis points or 0.16 basis points. That would be C. So let me go through that again just to show you how I calculate it. You take the original spot rates and you calculate a fixed rate. And that will give you 0.7951934. Add 20 basis points to the first and second, calculate your new discount rates, and then calculate your new fixed rate. That's 0.7967885. Take the difference between the two, and it turned out to be an increase of 0.16 basis points. Match the spot rates needed to calculate the corresponding implied forward rate. So here we have a 2-year implied forward rate in 5 years. So if we draw a timeline, in 5 years, we'll have a 2-year implied forward rate, which would bring us to the end of 7 years. So we're going to need a 5-year spot and a 7-year spot to get that done. A 5-year and 7-year spot rate. So A is 3. Next is a 3-year implied forward rate in 2 years. Draw our timeline out, go out 2 years, and create a 3-year forward rate. That would take us to the end of 5 years, which means we need a 2 and a 5-year spot rate. 2 and a 5-year spot rate, there's number 1, and a 5-year implied forward rate in 2 years. There's your timeline. Go out 2 years, create a 5-year implied forward rate, gets you to the end of year 7. You'll need a 2 and a 7-year spot. And there it is right there, 2-year and 7-year spot rates. Which of the following choices is the closest to the implied 5-year forward rate in 2 years for Swiss government bonds? So timeline, go out 2 years. We want a 5-year forward rate. That'll take us to the end of 7 years. We need a 2-year and a 7-year spot rate. There's our 2-year, there's our 7-year. We know it is the longest period rate over the shortest period rate. So it's 1, and it would be plus, but we have a negative rate. So 1 minus the 7-year rate to the power of 7, compounded for 7 years, divided by 1 minus the 2-year rate compounded for 2 years. The difference between 7 and 2 is 5, so it's 1 to the power of 1/5 minus 1. This turns into this. This denominator turns into this. Divide these two, take the 5th root minus 1. We get negative 0.1905. There it is over there with A. Match the sequence of forward rates and the corresponding spot rate that the forward rates will calculate. So here we have 0. So if we draw our timeline, 0 for 1 year, that's just a 1-year rate. Then we have a 1-year rate 1 year from now, which would take us to the end of year 2, followed by a 1-year rate beginning in year 2, which would take us to the end of year 3, 3-year spot rate. Next one, draw out our timeline. 0 and 1 year would take us to the end of year 1. Next we have a 2-year rate beginning in 1 year, so that would take us to the end of year 3. Next we have a 3-year rate beginning in 3 years, which would take us to the end of year 6. There you go, 6-year spot rate. And the final one, let's draw out our timeline here. 0 and 1 year, that takes us to the end of 1 year. Then we have a 1-year forward rate in 1 year, takes us to the end of year 2. Then we have a 1-year forward rate in 2 years, which would take us to the end of year 3. Then we have a 1-year rate in 3 years, which would take us to the end of year 4, 4-year spot rate. Which of the following statements about yield curves is true? I don't like this question because they're all true. Spot curves are derived from par rates. If you give me par rates, I can give you spot rates, and from those spot rates, draw a spot curve. Par curves are derived from forward rates. If you give me forward rates, I can give you the spot rates. If I have the spot rates, I can derive the forward rates, and with those forward rates, par rates, with those par rates, draw a par curve. Forward curves are derived from spot rates. If I have spot rates, I can calculate forward rates, and with those rates, calculate a forward curve. They are all true. Match the following statements about forward rate curves with corresponding statements about spot rate curves, and we'll just draw out an upward sloping spot curve and a downward sloping spot curve. If we have an upward sloping spot curve, the forward curve lies above, and if we have a downward sloping spot curve, the forward curve lies below. So number 1, the forward rate curve lies above the spot curve. That is this scenario here. So the spot rate curve is downward sloping? Nope. The spot rate curve is upward sloping. There we go. Next one, the forward rate curve lies below the spot rate curve. That is this scenario here. We see a spot curve that is downward sloping. That is here. And if we have a spot curve that's exactly flat, the forward curve will be exactly flat and identical. The forward rate curve is equivalent to the spot rate curve. The spot rate curve is flat across all maturities. Match the following statements about par rate curves with corresponding statements about spot rate curves. And the reading really didn't go into detail about negative spot rates, so I'll just draw it out for you here. If we have an upward sloping spot curve, you will have an upward sloping par curve just below it. If you have an upward sloping spot curve with negative rates, because of the way the math works out, the par rate shifts and the par rate sits above that spot curve. To show you, let's have an upward sloping curve with positive spot rates, 1%, 2%, 3%. We'll calculate our discount factors and the sum of the discount factors, and we know that our par rate will be 1 minus the last discount factor over the sum of the discount factors, 2.96%. Notice it is below 3%. It would be below the 3%. Now let's have an upward sloping curve with negative rates. You'd have -3, -2, and -1, right? -3, -2, -1 to create an upward sloping curve. Your discount rates, the sum of the discount rates, your fixed rate is -0.9856. Notice that this rate is -1, so you would have this situation where your spot is -1 and your par is -0.9856, which lies above that particular rate. So let's go. The par rate curve lies above the spot curve. Let's see, the spot curve is upward sloping and spot rates are negative. The par rate curve will lie above the spot curve. That is true. So A is 1 in this case. Let's put a number 1 in there. The par rate curve lies below the spot rate curve, which we have up here. The spot rate curve is upward sloping and spot rates are positive. Yes, there's number 2. And the par rate curve is equivalent to the spot rate curve. You get that if you have flat curves. The spot rate curve is flat across all maturities. There we are.